All right. We are over here. So we have so first of all we have the definition, right? So we have, and this is usually the way we do it, although you could have kind of different variations on this. So you have your node. So the node has, for example, an integer data, and it also stores next. And you have a head, which is there's just one of them, and that points to the beginning. So the way it would work is kind of like this. So you have like the head, and the head points to the linked list, which might be something like this. So does the structure kind of make sense?
Yeah, for the most part, that seems pretty good. One little syntax thing is when we're defining the node struct, it mentions struct node within itself. I was a little bit confused by that.
Right. So what we have here is we have an address of the next node, right? So it doesn't have struct node within itself, which wouldn't make sense. What it has is a struct node star next. So that means that inside of each node, what we have is we have the data and we have the address of the next node. So if you think about it, so this is kind of one way to picture it. The other way to picture it is you would say, okay, so I have my head, and I have node 1, and I have node 2, I have node 10 or whatever. And this is like 579. And it also has the address of node 2. And this also has the address of node 10. And this has null as the next, and head is the address of node 1, right? So node 1 contains the data, and it also contains next, which is the address of this guy, right? Is that making more sense?
Got it. Yeah, that clears it up. Thank you.
Okay. Okay. So that's like this. So now we can have kind of multiple multiple things that we could do. So we can, for example, append, right? So let's say that I want to have a function. So I'll quickly do a create. When did I disable it? Hold on. Okay. All right. So I'll do a create thing. And they'll do a create from data. So and do get I. So this is just the stuff that I've defined in lecture already. So feel free to stop me. All right. So here we have. So here we have kind of create L from data. We have get I. We already have append. So let's look at the append from lecture, right? So what we're doing with append is really the main thing is this. The main thing is saying, I want to go to the 5, 7, 9. So really like node 1, node 2, node 10. And then replace this null with a new node that has the new data. So the way we're doing it is we're saying I'll set up current to, for now, just be the first node. And then I'll keep updating current to current next, while it's not the case that current next is just null, which means that you've gotten to the last element in the linked list, right? So it's going to be that initially current is node 1, and then current is going to be node 2, and then current is going to be node 10, and node 10 next is null, so you'll stop. So it's going to be that current is node 10, right? So now at this point, we found the current to which we want to append the new node. And then we create the new node like this. And we're saying, okay, so we have this new node. So maybe we're going to call it like node 20. And maybe it has like 123, and then it's null. And what we want to do is we want to put 123 over here. And that means two things. So we want to say node 2 next is 123. So this is going to be address of 20 now. And then we also want for this to be null. All right. So over here, what we did is we made it so that new node is the address of the valid node with this data. And then we said current, which is the last element next, this new node, and we updated the size. So the only exception here is when the head initially is null. So that means that the linked list is empty. So if the linked list is empty, what you need to do is, again, create node and then also just directly say, well, the head is now the new node, as opposed to going through the linked list, which currently doesn't exist, and finding the last node there.
All right, that was really helpful. Thank you. Just the last sentence that you said about the head becoming the new node. Could you explain that a bit?
So the exceptional situation would be where there are no nodes at all in the linked list, right? So in that situation, the head is null. Because if the head is not null, then that means that it's a valid address of a node. So the linked list is not empty. So if it's empty, then we just want to make head be the new node that we've just created.
Got it. It's empty as in there's not a head and then no nodes after that. It's like literally nothing. There is no head existing in it yet.
Right.
Okay, that makes sense. Thank you.
Okay. Okay. Yeah. Sorry, I cannot. Oh, the chat now works. Okay, hold on. Okay, so that's Sam's question. How's everyone doing? Amazing. Okay. Array list. So array list, I should say, I believe I recorded array list the other day when I was doing one of the lab 4 maybe. But we can kind of quickly do it, I guess. Oh, and it was also in lecture, I suppose. Anyways. So okay. Actually, sorry. So this is going to take maybe a little while. So if anyone has like short questions, then maybe we should start with that. And then I'll do the array list. I don't have a problem with that. I just want to like answer short questions first. Anyone have any? Okay. Yeah, Arya.
Hello, Professor. I kind of just I really wanted to just clarify a few conceptual things
Okay.
when accessing a file.
Okay.
And I'm referring to question 4 of like the 2024 midterm, like the midterm solutions.
Yeah.
First of all, when do you know, like in a struct, to define something as a character versus an integer. Like when you in your solution, you said that like if you wanted to find a struct where you have um first number is a 10-digit student number and then it's followed by numbers representing marks. You said that you initialized in like your struct as car student number 11 and
Yeah,
then int marks. So I'm
yeah.
trying to understand, when do you use car and when do you use int?
Okay. So the answer is you could have used ints here if you really wanted to. It's just not that convenient, right? So this, like, even though it's digits, it's really more of a string, right? It's not an actual number, and in fact, it might be too large to store in an integer.
Okay.
So like you could also try to like just store it in like one long integer if you really wanted to, right? So this could be int, like if you wanted to read things digit by digit, you could do that. That's not a problem. This could not be car because here what we're doing is we are actually reading in those numbers. So like we read this into marks 0 and read this into marks 1 and read this into marks 2. At least that's the idea. And if it's like that, then there's no way to there's no way to make it car unless you make it like a bunch of car stars, because this is not a single character, it's two.
Okay, got it. And then
Okay.
on that note, when you went to like read in student from file, you
Yeah,
set like a buffer in a way of car string 100. I'm confused where you got 100 from, because today in lecture you also said that when you don't know the size of something, you should
yeah,
use
but here I did actually know the size because I said that there is at most 10 marks
per student.
per student. Yeah.
But then why did you put 100? Because you don't know how many students you have.
Oh, I see. Oh, maybe because I also said that there were at most, maybe there wasn't a reason to do that. Uh, student S. Uh, oh, okay, I remember. Yeah. I wrote it like that. Yeah. So first of all, you're correct. It never says that there is at most 100 students. I wrote this because we decided this way because we decided not to penalize people not considering this. You're right that there could be more students, in which case this would not work.
Okay, got it. And then just one final question. For highest average, exactly, how does it work? So like you go to file and then although it's technically the first function because it looks at just a file name, it goes through from reading all students from file, and then from there it goes into um read in student from file, and then it goes into read in student from string, and like
Okay.
so on and so forth. And then at the end, it goes into marks for each student, and then it calculates its average, right?
Okay. That sounds reasonable. So what's the question?
Is that correct?
Yeah, that sounds right. I mean, it's a little bit difficult to tell by ear, but that sounds about right.
Okay, then why did you, at the end, why did you put two statements where both of them were for loops and both of them talked about highest average? Like, I don't
This one?
understand the point of the last two paragraphs.
Do you mean like this stuff?
Yeah. Like, why did you
So the first loop finds what the highest average is, and then the second one finds the students who actually have that highest average.
Okay. Okay, got it. Thank you.
Yeah. Yeah, anything else that's short? All right, I guess we're doing array list. Hmm, okay. So we have our size and we have our capacity and we have our actual address of the first element in the block. So that would be like this. Here, what we're gonna do is create, stop me if I'm going too fast. I don't know what you want to hear about, what you don't want to hear about. So what are we doing here? I want to be able to create array list like this. So I want to say, make AL be a valid pointer to an array list. So I'm sending in the address of AL and I'm going to be setting AL inside creator array list, right? The way I'm doing it is I'm saying start the AL. So this means the same as AL malloc and has to have enough space to store those three guys. I then make the capacity be make the capacity whatever I said the capacity is, which means that array needs to store capacity integers. Size is the number of elements currently actually there. So there's nothing there, so it's 0. And I store capacity here. So in my main, that would be like this, right? So I start with AL, I create it. I say that the capacity is 10, for example. And that's the list. Okay. So let's do a few. So let's do like an example. So I'll do like get I. And the way get I would work is I want to get AL array at I, right? I will also check whether I is out of bounds. Like so. So I can also do a set I. And that would be the same. So I say array at I is equal to data. So now what I can do is set something and get something. So I can say like set 0 to 5 and 1 to 10, so on. So one thing I noticed is that this would not be allowed currently because the size is actually 0. So before I do that, I'll set the size before so that I can store all of those guys. So I can also do a function that would do it. So this is kind of like a manual way of setting things. And then I can print out one of those. So for example, like AL at 0. So I'm saying this and this. Okay, so get I should actually return an int. Okay, and that gets, F5. So let's do append, which I think is what we've done in lecture. So what does append mean? Append means ordinarily just the same as set, but sometimes when you append, you actually run out of capacity, in which case you need to do something more. So here, it wanted me to do this, but I'll do something different. So I'll say if the size gets at the capacity, I'll actually just reallocate. Right. So what I'm doing here is I'm saying, okay, so if AL size is the same as capacity, which means that I'm not allowed to say like AL at size, which is what I would ordinarily do over here. I'm saying, okay, so just double the capacity and then reallocate so that I actually have this capacity. So AL array is now going to be of size new capacity times size of it. Right. So, and then whether I reallocate or not, what does append mean? It means go to this index and set it to data, right? So far you had indices from 0 up to size -1, and now you also set AL array at this new index, and you increase the size now that you've appended. So we can try it. Sure. And now I'll also print AL at 4, which did not exist before. '24. Okay. So I'll kind of come back to those which are, I think, kind of the difficult ones. And I guess kind of, can you let me know, like, is this okay? Does anything not make sense? Stuff like that.
I have a question.
Okay.
So we are doubling capacity if our array list size equals capacity. Can we actually use plus equals 1 instead of doubling it?
You could. Yeah.
Mm-hmm.
So yeah, so this is kind of basically it's a question of how you are planning for it to be used. So you might imagine that it's more efficient to double the capacity so that you don't have to reallocate all the time if you're appending a lot. Or you might imagine that you don't want to grow the capacity by too much, in which case like doubling might be too much.
I also got another question. How are we going to use a void remove function for this array list?
How are you going to use remove? So
Yep, we just
yeah. So remove is like remove in Python, right? So the goal here is, so first of all, what's the goal? So if the list right now is like 5, 10, 23, is that right? Yeah, 10, 24. Yeah. Then you can say, well, like I want to remove the thing at index 1, so I want to make the list be this. Right? So that's the goal. So how do you remove? Well, like you could do it like that, of course, but I'll do it with move. So here essentially we're saying like if you want to remove index j, so just move everything. So basically what we're doing here, right, is we're saying like move each of those to the left, like so.
and including the null at the end.
Well, so the null, so there's not necessarily nulls at the end there. So nulls are specifically for strings.
Mm-hmm. Right. Thank you.
Right?
Just another question.
Graph of where the array list ends is, we just know the size.
Mm-hmm. Okay. Can I just make another question? So, is the midterm gonna involve a lot of file reading codes like a fget and scanf?
Um, the only information I can give you is that scanf was never in any of the materials that you saw this semester officially.
All right, thank you.
Yeah, so I'm just like, yeah, like I'll see, like I can't tell you what's in or not in the midterm. Except like
Okay.
if something wasn't done in the material, like scanf, then no.
Okay, thank you.
Sorry, really quick question. What does mem move do again?
Yeah, so mem move says move this much of the content from here to here. And mem move, unlike mem CPY, uh, allows for the source and the destination to overlap like they do here, right? So essentially what we're saying is if we want to remove the 10, then we want to move this chunk to this location. Right?
Okay, and
the way we're doing it
yeah,
is we're saying, I want to move from this location to this location, and the chunk is of this size.
what if the destination is not big enough?
So C does not check. So in principle, you could have a situation where it would just crash if you didn't take care to make, like this could also just not be a valid address anyway, not big enough. But yeah, so C does not check, it would just crash.
Thank you.
Hello again, Professor.
Uh,
I just had a quick question again. Once again, it's the 2024 midterm.
okay.
Um, sorry. When do you know to when do you know to use malloc in a file accident question and like when not to? Because in this question, if you look, there's like no malloc. But then like most file accessing questions, they require malloc. So like when should you use it? When should you not?
So kind of the glib answer is like you use it when you need it. So when would you need malloc? You would need malloc if you don't know in advance how much data you're reading in, right? So if
In
you
this case, you don't know.
so in this case, like maybe you or maybe someone else pointed out, I actually like made the simplification in the solution where I assumed that there is at most 100 students, which might not be the case. So here, like actually, if I wanted to account for a situation where there could be more than 100 students, I would need to use malloc as well somehow, because I would need to read in data for more than 100 students.
Okay. Okay. And okay. That makes sense. Thank you.
Okay. Does anyone else have anything? All right. Well, good talk. Okay. I will see you tomorrow. Bye.
Thank you, Prof.
our size, and we have our capacity. Finds the students who actually have that highest average. Capacity, I'll actually just read out.
And including the null at the end.
Well, so the null, so there's not necessarily nulls at the end there. So nulls are specifically for strings.